This is a video on factoring trinomials. And the first step when you're factoring trinomials is to look for a GCF. That's true actually if you're factoring any algebraic expression. You should always look for a GCF first. It's no different for trinomials. Then the procedure is to write out the factors for the first and the last terms and to use those terms to figure out which ones you can use to get to your middle term. That'll tell you which are the correct factors. And one important thing to do before you go through the factors is to determine if you need two of the same sign or two opposite signs. And I'll show you what I mean by that. Here's example 1. Factor this trinomial, x squared plus 9x plus 18. The first step is to look for a GCF. GCF means a common factor of all three terms, and here there is not one. So we'll skip to the next step. We'll list out the factors of the first and last terms. And before I list out the factors, I'll always look at this sign of the last term. That's going to determine if I have to have two of the same signed factors or two opposite signs. And the fact that this is positive means that my factors both have to be the same sign. I need either two positive factors or two negative factors, because when I multiply them, that's the way to get a positive result. And the fact that this term is positive tells me that I'm going to need two positives as opposed to two negatives. Okay, so that's going to help when I'm looking for a sign. Now I list out the factors of the first and the last terms. The factors of x squared are x and x. I'll always list out factors so that each factor will have x's in them. Why is that? Well, it's because that middle term has an x as well. And you'll see when we distribute that we are going to want our middle terms to have x's in them. So I'm going to list out the factors here to both have x's. The only way to get 1x squared is with 1x times 1x. And then the potential factors of 18 are 1 and 18, 2 and 9, and 3 and 6. There are three possibilities. I list them all vertically. 1, 18 together is one set, 2, 9 is one set, 3, 6 is one set beneath the 18. Factor of 18. Now what I need to do is I have to find the combination that will get me the middle term. So by combination, this is what I mean. I'm going to pick a combination, and when I pick one of the factors, I'll multiply the factor from this blue set from the first term times one of the factors from the red set. So what I'm going to do is, as an example, let's say I picked this 9 and this 2. So a couple of things about those. One is that when I pick the 9 and I join it with the x, I have to pick one set from over here and one set from over here. I multiply the x times the 9. That's where I get that 9x. It's multiplied and I write it over this arc. And this x and this 2, I multiply them. That's where I get 2x. X times 2 is equal to 2x. And the other thing that's important is that I have to use numbers from the same set. Because I use the 9, I have to use the 2. I have to use two numbers that multiply to 18. I couldn't pick the 2 and the 18 together, or the 1 and the 9 together. I have to pick two numbers that both are part of the same set of factors of 18. Okay, so I end up with this 2x and this 9x. Now, is there any way to get to 9x using 2x and 9x by either adding or subtracting those terms? And here, there is no possible way to do that. If I added these two, I would get 11. If I subtracted them, I would get 7. Or negative 7. There's no way to get 9, which means that 2 and 9 is not the correct combination. So I'll have to look for another one. Suppose I tried this combination. Remember that when I join these, I multiply them. X times 6 is 6x, x times 3 is 3x. Is there a way to get to 9x using these two factors? And yeah, there is. If both of these were positive, I had a positive 3x and a positive 6x, and I added them, they would add up to 9x. That's my middle term. That's what I want. So that's good. Now what I do is I take the sign over here, the positive, and it follows the arc to the number in the set of factors all the way on the right. That positive from positive 3x follows the arc, ends up with the 3, and this positive follows the arc and ends up with the 6. These are going to be numbers in my factor brackets, and here's how I put them together. The numbers that are connected by this line, they have to end up in opposite brackets. So the fact that these are connected actually means that the x and the 6 end up in the same bracket. And the fact that these are connected means that this x and this 3 end up in the same bracket. Why is that? Well, it comes from the fact that as a check, I would distribute these. And when I distribute these, when I multiply them out, I get x times x, I get x times 3, 6 times x, which is 6x, and 3 times 6, which is 18. So that is equal to this when I group the like terms. That's good. But also, and importantly, these middle terms, 3x and 6x, those are the numbers that were over these arcs. That is done on purpose. That's by design. We made this to work out that way. That's how we figured out that we were going to get the middle term. And to end up with a 3 times x, that 3x, I had to make sure that my x and my 3 that I connected with a line are in opposite brackets. They're in the other bracket, one from the other. That's how I know that I'm going to end up multiplying them when I FOIL. That works. Example 2, x squared plus 5x minus 14. If you want to pause for a second and look for a GCF, I encourage you to do that. In this case, there is no GCF. And so I'll skip to listing the factors. And again, if I look at sign quickly first, this negative 14 means that I'm going to need one positive and one negative factor. Okay, so we'll keep that in mind when we find our factors. The factors of x squared are x and x. The factors of 14 are either 1, 14 or 2 and 7. And the way to get to that middle term of 5x, I mean, you might already see that if I used 1 and 14, I'd end up with 1x and 14x, and there's no way to get to 5. It means that the winning combination, and remember that we're going to need one positive and one negative, is going to be the 7 and the 2. And I write them this way just to show that in some cases I might connect by an arc, in some cases I might cross them over. In some cases it will matter, in this case it actually didn't. We'll see one in 2 more examples that will matter. And remember that because I need one positive and one negative factor here, and I want to end up with positive 5, the way to do that is to make this one positive, positive 7x, and remember the positive is going to follow this line, end up with the 7, and negative 2x, and remember that negative is going to follow the line and end up with the 2. So the ones that are connected with a line have to end up in opposite brackets. X and plus 7 have to end up in opposite brackets, which means these two go together. When I'm factoring, I actually circle these. I make sure that I know that those two end up in the same bracket and that these two end up in the same bracket. And as a check, and I will always check, I'll distribute this out. X squared plus 7x minus 2x minus 14 works out to be exactly what we wanted. And those two middle terms came from here. That's the connection. That's where they come from, and that's why this works. It's good. Example 3 is almost exactly the same. If you want to pause and look for a GCF and pause and try to list the factors to see if you're right, now's a good time to do that. But I'm just going to skip ahead and show you. There's no GCF here. This negative means that we're going to need one positive and one negative factor. And when I list out the factors, I've got x and x. I've got 1, 14 and 2, 7. That looks familiar because this is almost the same as example 2. And when I'm looking for the combination that works to end up with negative 5x, 2 and 7 is still the winning combo, but to end up with negative 5x, I have to have a negative 7x, that negative follows here, and a positive 2x, that positive follows here. And again, the ones that are connected end up in opposite brackets, so x and positive 2 end up in the same bracket. That's one factor. And this x and this negative 7 end up in the other bracket. And as a check, if I multiply that out, everything works. Negative 7x plus 2x is negative 5x. Perfect. And these two middle terms are these two. They correspond. It's perfect. Okay, final one. Again, if you want to pause the video and look for a GCF and see if you can list the factors, go for it. Now's a good time. So as opposed to the first 3, this example does have a GCF. All of these are divisible by 2. I will take that out first. That's going to have to be written in my final answer, but we'll get to that in a minute. So I'm going to move on to listing the factors, and this negative means that I'm going to need a positive and a negative when I'm listing my factors. So I'm just going to list the factors for the 2x squared and the negative 5. I'm not going to do anything with that 2 yet. I'm just going to keep it outside the bracket, and I'll rewrite it in the final answer. But when I list the factors, I'm going to have x and 2x. And 1 and 5, there's only one possibility here. 5 is a prime number. And I'm going to look for a combination that will get me 9. And remember that the numbers that I end up with aren't necessarily just 5 and 1. It's the product of the first and the last term. For most of the examples we've done, the first 3, that just ended up being this number, x. But in this case, because there's a coefficient here other than 1, I do actually have to multiply. And here the combination that works is to multiply x times 1, that's 1x. And 2 times 5, or 2x times 5 is 10x. There is a way to get to positive 9 from that. I would have to have, remember that with one positive and one negative, I need one of each to get that negative 5. I would have to have negative 1x and positive 10x. that negative follows this line. It's going to make this a -1, and the positive 10x is going to follow this arc and give me a positive 5. And remember that the ones that are connected end up in opposite brackets. So that means that the x and the plus 5 end up together, the 2x and the -1 end up together. And when I write those factors down, I have to remember to write that GCF outside. That is part of the answer. And when I check my answer, when I distribute, the order of operations is that either I can FOIL first and then distribute the 2. That's what I did here. If I multiply all that out, I would get back the original trinomial that I had. Or you could distribute the 2 to one of these two and then FOIL. Either way, you'd get the correct answer. All good. That's the